let's do this problem here. The question is asking find the best description of span 1123 minus 10 402 402. So to find the answer, what we have to do, we have to arrange this in rows. So 1123 minus 10 402. Then we have to do the Gaussian. Whatever the vectors that is left, that's going to be the linearly independent vectors. So let's see. So now I can do the Gauss theorem for this one. If I do that, this will become 112, and I can eliminate. I have to make whatever the value below and above the pivot to 0. So to make this one to 0, I can multiply the first equation by -3 and add it to the second equation. So if I do that, I will get minus 3r1 plus r2. That's going to give us 0 right here. And minus 3 times 1 is going to be minus 3, plus minus 1 is going to be minus 4. Then minus 3 times 2 is going to be minus 6. Minus 6 plus 0 is going to be minus 6. Then I can do the same thing to the third row. That's going to be minus 4r1 plus r3. If I do that, I will get 0 right here. Then minus 4 times 1 is going to be minus 4. Minus 4 plus 0 is going to be minus 4. And minus 4 times 2 is going to be minus 8. Plus 2 is going to be minus 6. So if you notice that we have second row and the third row with the same numbers, so we can eliminate one of them. So if I write this one 112, then the second column is 0 minus 4 minus 6. For the third row, second row is 0 minus 4 minus 6. For the third row, I'm going to multiply the second row by negative and add it to the third row. So if I do that, the third row will become 0 0 0. And to fully solve this into Gauss-Jordan pattern, I can divide the second equation by -4 to make this one into 1. So this one is 1 1 2. If I divide the second equation by -4, this will become 0 1 3 by 2. And then to eliminate the value above the pivot to 0, to make the value above the pivot to 0, I can multiply the second equation by -1 and add it to the first equation. So if I do that, I will get R2 minus R2 plus R1, which is going to give us 1 0 minus 3 by 2 plus 2 can be written as 4 by 2. So 4 by 2 minus 3 by 2 is going to become 1 by 2. 1 by 2, and the second one is going to be 0 1 3 by 2, and the third one remains as 0 0 0. Now we have fully solved this matrix into Gauss-Jordan pattern. So from this one we can answer this question. So the question is asking find the best description of span. So the final answer is going to be span of, because the third is linearly dependent, the first two are linearly independent. So we have to write the first two. That's going to be the best description. So first two are 1 1 2 and 3 minus 1 0. So that's the linearly independent vectors, and that's the answer for the first question. The second question is asking about column space, row space, null space. To find these things, I had to do the Gauss-Jordan for this matrix. So if I do that, let's see what I get. So to make the second row first column and the second row third row first column into 0, to make the second row into 0, I can multiply the first row by -1 and add it to the second row. So negative r1 plus r2, negative 2r1 plus r2 is going to give us 0 right here, and this is going to be 1. Negative 2 times 2 is going to, negative 2 is going to be plus 4 plus 3 is going to be 7. Then if I do the same thing to the third one, it's going to be negative 3r1 plus r3, which will give us 0 right here, and the second column is going to be negative 3 times 0 is 0, plus 1 is going to be 1. Negative 3 times negative 2 is going to be plus 6 plus 1 is going to be plus 7. If you see that second row and third column has same numbers, so we can eliminate one of them. So we can multiply the second row by -1 and add it to the third row. So it's going to be negative r2 plus r3, which will give us 0 0 0. And from this one, now it's already in the Gauss-Jordan pattern, so we don't have to do anything else. So from this one we can answer everything. So the best description of the column space is going to be the column with the pivots. If you see, the first column we have pivot and the second column has pivot. So we have to answer we have to write these two columns as the answer. So the answer for this one is going to be column space A is equal to span of the first two columns, the columns with the pivots, right? So it's going to be 1 2 3 and then 0 1 1. So this is the answer for the first question. The second question is asking to find the row space. Row space is basically the columns with the row space is basically the rows with the pivots. So if you see, first row has a pivot, second row has a pivot. So those are the rows that are going to be in the row space. So row A is equal to span of the first row is 1 0 minus 2, 1 0 minus 2, and the second row is 2 1 3. And that's my answer for this question. And the third question is asking find the null space. To find the null space, I have to set this one into 0 and solve for this one. So null space is basically Ax is equal to 0. So we have done the Gauss run already, so we can bring this pattern and solve for this one. So this is going to be 1 0 minus 2 0 0 1 7 0, then 0 0 0 0. And from this one we know that our free variables is C, because the third column doesn't have a pivot. So that's why we choose the C. C is the free variable. So I had to answer everything in terms of free variable. So let's bring the equations. So for the first row, the equation is going to be x minus 2z is equal to 0. Therefore, x is equal to 2z. For the second row, the equation is going to be y plus 7z is equal to 0. Therefore, y is equal to minus 7z. Now I can answer this one as 2z minus 7z, and c is going to be z because it's a free variable. And if I take the z common, it's going to be 2 minus 7z, minus 7 1, because I'm taking the c common. So 2 minus 7 1. So I can write this one as null space. A is equal to span of, when I write the span, I have to eliminate this c, because c can be any real number. So we don't want that. We want the basic format of this one. So that's going to be 2 minus 7 1. Therefore I have to answer this one as span of 2 minus 7 1. And that's the final answer for this question. And that's all it is. I hope you guys like this video. See you next time.